Hi guys, welcome back to Math with April. So today we will be doing this question about integration by substitution. So let's get started. So, okay, we see the question. It's basically substitution, yeah. So this main integration part, it's worded so weirdly, but we can look at it as 1 over 2 plus cos 2x dx. This might perhaps make it easier for you guys to see. So anyways, we know that s is equal to tan x, right? So whenever we see this, I always differentiate this, which ds over dx will be equal to sec square x, and dx will be equal to 1 over sec square x times ds. So okay, now we can move on to the main part, which is the integration of 1 over 2 plus cos 2x dx. And we know from here that dx is equal to this, so we can substitute that in. So 1 over 2 plus cos 2x times 1 over sec square x ds. Right? And also take in mind that cos 2x can be equal to 2 cos square x minus 1 or 1 minus 2 sine square x. For me personally, I will choose 2 cos square x minus 1 because eventually it can cancel up sec square x, because sec x is basically equal to 1 over cos x. You guys should know that. So as we substitute, it can be 1 over 2 plus 2 cos square x minus 1 times 1 over sec square x ds. So this will be equal to 1 over 2 cos square x plus 1 times 1 over sec square x ds. So what we can see from here is we're kind of stuck, right? But another method that is really useful for this is we can look at s as a right angle triangle. So we can say that s over 1 is equal to tan x, right? Which we can draw out a right angle triangle and make x an angle. So tan x is equal to s over 1. Tan is basically opposite over adjacent, so will be s over 1. And then the hypotenuse will be s squared plus 1 squared. So from here, from this right angle triangle, we can say that cos x, which is equal to adjacent over hypotenuse, can be equal to 1 over root s squared plus 1 squared. And sec x can be equal to s squared plus 1 squared. So from here, we can see that these are the same, right? And can substitute the green value into our main part. So we will be integrating 1 over 2 times 1 over root s squared plus 1 square plus 1 times 1 over root s squared plus 1 square ds. So now we have the s values that we can integrate. So eventually the roots will cancel out with the square. So confusing. Which will lead us to 1 over 1 plus 2 over 1 plus s squared times 1 over 1 s squared. I'm going to write 1 plus s squared, it's easier. 1 plus s squared dx. So now when we get that, we can times them together. So this will lead to 1 over make it really big. Actually, no, like 1 over. So we can do this, go up to times that, which will be equal to 1 plus x s squared plus 2 over 1 plus s squared times 1 over 1 plus s squared ds. Which from here we can see that this will eventually go up there, which we can cancel these two out, which it will be 1 over s squared plus 3 ds. So what we can do here is that the main key idea to integrate this part, is to note that the integration of 1 over a squared plus x squared will be equal to arc tan x over a. So we have to write this as this form in order to integrate that. So what we can do is we can expand 3 out, which will give us 3 times 1 square plus s over root 3 square bracket. This will eventually give us 1 over 3, because we can expand this part out, right? And integrating the inside part will be arc tan s over root 3 over 1 over root 3 plus c. Then this would be equal to root 3 over 3 arc tan 1 over root 3 tan x plus c. This is because s here, I'll make another color, is equal to tan x, therefore tan x here appears, which we answer the question correctly in the form of a arc tan b tan x plus c. So we can give the answer is, this is the correct answer right here. And yeah, that's how we integrate by substitution. Hope you guys enjoy. Good luck.